Now we'll be looking at diagonalization of a matrix. Please look at the eigenvalues and eigenvectors and homogeneous and non-homogeneous equation for better understanding. We'll solve few problems on it also. Please like, share and subscribe this particular channel. Let us start now. Now coming to diagonalization of a matrix. It is denoted by D. Okay. Coming to definition, a square matrix A n cross n is said to be diagnosable if P inverse A into P is equal to D. Okay. This is a general definition. Okay. But we know that the A minus lambda I into x is equal to 0 or Ax is equal to lambda x for eigenvalues and eigenvectors, right? Where A is nothing but n cross n matrix. If you consider A as a 3 cross 3 matrix, okay, and lambda is nothing but eigenvalues. And if you consider for 3 cross 3 matrix, it becomes lambda 1, lambda 2, and lambda 3. And x is nothing but eigenvectors. Then for 3 cross 3 matrix, it becomes x1, x2, and x3. If you write all these particular values in the form of matrix, x1 in the form of a column matrix, x2 in the form of column matrix, x3 in the form of column matrix, and combine all the eigenvectors in a whole one matrix, it is known as P. Okay. Now when you multiply P inverse A and P, we get a value of D, where D is nothing but diagonal elements would be nothing but eigenvalues and other values are 0. So D is known as a diagonalization of a matrix, which is nothing but P inverse A into P. I'll be showing you the steps how to solve the problems. Now we'll be looking at the steps to follow to find the diagonalization of a matrix. Okay. Now first one is find the eigenvalues, okay, of a matrix A. Next step is nothing but find the eigenvectors and P value. And third step is nothing but find the value of P inverse. And fourth one is find the D, which is equal to P inverse A into P. Right. This is the method to find the diagonalization of a matrix. Now basic note point you have to remember is nothing but A is equal to P into D into P inverse. As you know D value, P inverse A into P, then A is equal to P into D into P inverse. A power n is equal to P into D power n into P inverse. And D power n is also equal to P inverse A power n into P. And A is equal to D is equal to P inverse A into P if A is in a diagonal matrix. This is a basic note point you have to remember. Okay, we'll be solving one of the problem of it. Now coming to the question. The question is, for a given 2 cross 2 matrix A, it is observed that A into column matrix is equal to minus of some column matrix, and A into some column matrix is equal to minus 2 times of a column matrix. The value of A is, okay. Now if you see this one, it is in the form of A into x is equal to lambda times of an x. Yes or no? So we can see that lambda value is equal to nothing but minus 1 comma minus 2, and x1 value is equal to nothing but 1 minus 1, and x2 value is equal to nothing but 1 minus 2. These are my eigenvectors. These are my eigenvalues. Now you have to find the value of an A. The basic thing that we know is nothing but A is equal to nothing but P into D into P inverse, right? What is a P? It's a combination of vectors, right? So eigenvectors. So it becomes P is equal to nothing but 1 minus 1, 1 minus 2. What is D? Is nothing but diagonal elements or nothing but eigenvalues. So it becomes minus 1, 0, 0, minus 2. Right? So we have to find the value of P inverse, which is nothing but it is 2 cross 2 matrix. So it becomes 1 by minus 2 plus 1 into minus 2, 1, minus 1, 1. Right? Just multiply it. We get this one as it becomes minus 1. So it becomes 2, 1, minus 1, minus 1. So A value is equal to nothing but P. P is nothing but 1, 1, minus 1, minus 2. D is nothing but minus 1, 0, 0, minus 2. And P inverse is equal to nothing but 2, 1, minus 1, minus 1. This is an A value. So we can see that in the option, it got satisfied in the option C. So answer is C.